Now, that's it's a great view of the structural side of things. I know that there's also simulation options beyond just structural simulation. SOLIDWORKS has SOLIDWORKS flow simulation, and there's plastics. What else? Is there any other tools that are connected now available to SOLIDWORKS users through the 3D Experience platform?
Yeah, absolutely. So we, as you had mentioned, we do have our plastics and our fluid dynamics, which I guess technically speaking, both are fluid dynamics.
Yeah.
So those tools are also available on the platform as they are on the desktop. The big new change that we have, and it's not a new code, but new to us, is electromagnetic simulation. So from a 3D Experience platform perspective, the tool is called Electromagnetics Engineer. It lets you understand like electromagnetic fields. A lot of people use it for antenna placement. You can use it to understand electromagnetic fields of batteries. Like it's not something that we as mechanically minded folk typically think about, but it's really important to understand if you're going to have your parts work better, especially as things become more interconnected. So the more interconnected things become, the more electronic components are on them, the more antennas, the more receivers that need to be able to work how they're supposed to work. And that type of simulation, which is arguably a type of flow as well, is now available.
I mean, we're looking at something that was available conceptually to SOLIDWORKS users and extending it with the simulator-based structural, but the electromagnetics is a totally different field that SOLIDWORKS has had no touch with and been completely disconnected. Now, I know that CST Studio is another name that's related to that. How is that related to the electromagnetics engineer role?
So it is the Simulia desktop product equivalent to that 3D Experience platform role. So for all intents and purposes for us, it is the same tool. It's just how do you need to use it?
So similar conceptually to Abacus is the traditional desktop version. This is using the same technology as Abacus, the same solver. CST Studio solvers are available in Electromagnetics Engineer. For people that are already familiar with CST Studio, they'll be able to pick right up with the Electromagnetics Engineer.
Yeah, exactly right.
Yeah. Now, and then with the plastics and the flow, there's SOLIDWORKS flow, and then there's SOLIDWORKS plastics, but there are additional similar options in this flavor as well, correct?
Yes, there are. So if we are going to use the flow example, we have Fluid Dynamics Engineer would be the equivalent product on the platform. It has more capability. It's got the ability to use cloud solving, which means that we can solve things a lot faster. Those big assemblies or those big flow problems, they're a lot easier with the Fluid Dynamics Engineer tool. Another big benefit of doing that is the ability to do that more complicated meshing, right? Yeah. We do have some more powerful codes for specific applications within the fluid dynamics space as well, if we're talking general purpose fluid dynamics. Mm-hmm. Then if we get to an explicit manufacturing solution, we have our plastics products. So for those that have probably been familiar with our SOLIDWORKS offering, we do have plastics standard, pro, and premium. We have a tool called a plastics engineering. This is that role on the platform, right? It is plastics premium. That is about the same level of capability, but again, with those added solvers. Yeah. And those are developed kind of in tandem. So like they have the same capabilities that typically get introduced.
Awesome. Now, know that we're getting close to end on time here. So as we look out, and we've talked a little bit about what would define somebody to go and look at simulation in general. We talked a little bit about what would define someone to go and look beyond SOLIDWORKS simulation if they already have that and they're reaching the limits of their capabilities with premium. Is there any other is it the same concept for basically anything? If you're running in, how do you know if you have something for, say, electromagnetics engineer? How do you know when to start looking for some of those other things? Especially like electromagnetics engineer is especially one that would be not necessarily intuitive for you to see a problem with. Where are some triggers in industries and places that might use some of those capabilities?
Honestly, the best case scenario is to give you guys a call and have a conversation about it. That's truly the easiest way to understand it. because a lot of engineers don't think about that sort of stuff. But just to give you a flavor or a better, like a trigger is what you're looking for here. If you have electronic components on whatever you're building, there's probably a use case for it. If you have any kind of antennas on your product, there's probably a use case for it. If you have any kind of high voltages running through your part, there's probably a use case for it. It's more useful than you'd think. And actually, you can do some fluid dynamics applications and some thermal applications in it. It's got a lot of different things that you can do there. It's one of those tools that just really works well. Yeah. I say this about our flow codes as well. They do a good job. I mean, all of our codes are great, but I really found when I was picking these tools up, the electromagnetics tools, they're just really intuitive, especially for someone that's not of an electromagnetic background. Like I don't have an electrical engineering background. I have a manufacturing background. It's a lot less complicated than you might think.
And then one last question for me. We've got all these different options. Is there any way to interconnect the different like flow sim and structural sim and have those results interconnect? I know that SOLIDWORKS is all in that one interface. Can you do similar capabilities with this?
So the term that we use in the SOLIDWORKS side of the portfolio is results exchange, and you can do the exact same thing here. I can understand some of the results from here, and I can bring them over into another study, and I can use those for another type of simulation. It is pretty seamless. It's pretty straightforward. You can share those very easily. Yeah.
Awesome. Well, that's all I have on my end. Anything else that you'd like to share? Or any other questions from your end, Mitch?
I have one just to kind of wrap it up as a concrete, like next steps for someone listening.
Yeah.
If they're interested, what type of, I guess, analysis should they be doing? Should they be looking at like how much time are my engineers spending as I'm designing, price analysis, where are they losing cost? What do you kind of give as like a next step as a baseline? Obviously, calling us should be probably the next step, but outside of that.
I'm not going to miss an opportunity to say it depends because it super does.
Good way to close that.
Yeah,
perfect
it depends. There's quite a few different things you can look at. Just you should give SWYFT a call. They're the ones that can help you figure that out. But if you're looking for some things to start, look at how much time you're spending on rework for existing parts. Look at your warranty issues. Are things breaking? Are things not working how they're supposed to? How much time are your engineers spending on a design if they don't know that it's going to work right away? How much money are you spending on physical testing? How long does it take to do physical testing? Does physical testing account for everything you need it to do? Anywhere in the design process that you are unsure of the result, a simulation can usually help you with that.
Awesome. Well, I really appreciate your time. It's been a pleasure having you, and give us a call if you have any questions about simulation. We're happy to talk through what you're doing, help you create a plan on how to test if it's going to even be worth your time at this time and when it would be. So we're always happy to help.
Awesome. Thanks, Drew.
Thanks for having me.